Okay, for this one, you do need to draw a free body diagram. It's a dead giveaway because they ask you to find the magnitude of a force. And whenever you're trying to find forces, you have to draw free body diagrams. Okay, so in this problem, it's silly to try to draw a free body of the yellow straight rod because somebody has got their hand on this thing, driving it, holding it, making it move at this particular rate. It doesn't do that on its own. So I don't care how much that force is that's on the rod, and I don't know what it is, so I'm going to ignore it by not drawing a free body. So what I'm going to do is I'm going to draw a free body diagram of these two links, or the two collars, all by themselves. By the way, I don't want to draw a free body of the hoop because someone is holding it down, and I don't care how much they apply force or anything else, so I'm going to ignore that. So I'm going to just draw those collars. Now, normally you should draw the collars over off to the side and then draw the forces on them. But in order to show more clearly the geometry, I'm going to try and draw. I'm just going to zoom in. I'm going to draw the forces on the mechanism itself. But this is probably not a good practice. But if you'll just bear with me for this while I do it. Okay. So what I'm going to do is draw the forces that exist on these, the inside-outside forces. Obviously, you have mg down, so I'm going to draw that in. So this is mass times gravity this way, mg. Okay, then you look for contact, and I have contact coming from the straight mechanism, so I'm going to just draw this black line right here. And so if you happen to have a normal force from this, or you will rather, it'll go this way. So I'm going to draw it this way, and I'm going to call it P for pressure, and I'm going to call it S for straight because it's coming from the straight mechanism. And notice that this thing is perpendicular to the straight arm, always is. If you happen to have friction on this, if you decide it has friction, then what you want to do is you want to draw a friction force, and the friction force is
narrator dialogue, exiting narrator.
What you want to do is draw the friction force, and it's sliding, and so the friction is always parallel to the surface, right? So I'm going to draw a line this way that's parallel to the surface. It's sliding, so the magnitude is equal to mu k times the pressure holding them together. That's the P straight pressure. So that's the magnitude of that friction force. And now you have to get the arrowhead. Now the hard part about friction on these mechanisms is trying to determine whether which way the slipping is occurring. And that can be difficult. On a test, I will tell you if I have that on the if I have a friction on the mechanism, I'll tell you which way it's sliding. So what you have to do is kind of think about it. It looks to me like, let's zoom back out, that if this guy is actually rotating counterclockwise as shown, the distance between B and O is getting shorter, which tells me that the collar is sliding inward on that thing. So since the slide is inward, the friction force always opposes that, and so it's going to push it out back that way. So the arrowhead goes this way. Okay, so that's that one. What else do you have? Well, you have contact on the, it looks like it's blue, so I'm going to put these in blue. You have contact on the blue thing, right? And so it'll have a pressure, and the pressure is going to be perpendicular to the tangent to this thing. So I'm going to try and draw a tangent in here. So that looks to me like that's the tangent direction right there. So it'll have a normal pressure, and that normal pressure is perpendicular to that surface. So this guy here is 90 degrees. And let's call that P for pressure, and it'll be C for curve, because it's coming from the curved body. If this guy also has friction, then the friction will be parallel with that surface. So I'm going to draw a stick here. That the friction force, if it has one, it would be here. It's kinetic, and so the magnitude is going to be mu k times the pressure holding them together, mu k pc. And then the arrowhead is determined by which way the slip is going. Well, let's zoom back out. If this guy is going to the counterclockwise, that collar is moving up and left, and so friction opposes that, tries to stop it, so it's going to be this direction here. Anything else? No, there's nothing else because there's no other contact. Okay, so now once you draw the free body diagram, what you want to do is ask yourself, what direction do you want to sum forces in? In this case, it's not tangent normal because they're not telling you anything about the speed or anything of that sort. It's not certainly not x and y, and so the one that looks best is the r and theta. So I'm going to choose r and theta. When you choose r and theta, you want to first of all find the correct directions. Now you might be tempted to say this is the radial direction, and that is not right. That's not the radial direction because the radial always goes from the origin, which is where you're measuring the r and the theta from. So it's going from this point over here through this point right here. And so you draw a line there. So this case would be the radial direction goes this way. So I'm going to just zoom in. And so the radial direction is this way. It's the nr. This is not a force, that's just direction. And the n theta is going to be perpendicular to that, which is this way. So that'll be the n theta. And if you notice, the ps is parallel with the n theta direction. So those are your two directions. So in order to do this, now I'm going to sum forces. Well, the black forces are lined up nice and beautiful, no problem. But the blue forces, I'm going to have to figure out this angle. So what I would like to find is I would like to find, and say this angle right here. Let me put it in blue. So I'd like to find this angle here. Well, it turns out that there is a formula. It's given in the book. It's also given in the references that I give you that will find the angle between the r direction and the tangent line. Okay, so let's remember where the tangent line is. The tangent line is this blue one. So this guy right here, this is the tangent line. And so I have a formula that will tell me the angle between the r direction. Let me put it in the green. So I have a formula that will give me this angle right here. And what I'm drawing is a positive angle, and the formula calls that psi. Okay? Now, the formula for getting psi is, I'm going to pause it so I look it up. Okay, formula says that the tangent of the angle psi is equal to r divided by dr d theta. Okay, so let me find the expression for r. See it right here. So r equals 1.6 cosine theta. So dr d theta is equal to a negative 1.6 sine of theta. Okay, so the angle theta is 45 degrees. So dr d theta is equal to minus 1.6 sine of 45, which is equal to, I believe this is equal to a negative 1.13. All right, this guy is equal to, I should have known better, this is equal to 1.13 also. Cosine of 45 is the same as sine of 45. So anyway, that's why they're the same. It's coincidence. Alright, so anyway, the tangent then is equal to 1.13 divided by a negative 1.13. So if you take the inverse tangent of this, that would be equal to a negative inverse tangent of 1 is equal to 45 degrees. It's a negative, so it would be negative 45 degrees. Okay. So the angle is a negative 45 degrees, and that would be this guy right here. So this is the positive psi is in the direction of positive theta. So if you get a negative psi, it's going to be back this direction. It's opposite. So you go back. So this angle right here is 45 degrees between here and the other tangent line. Okay, so negative 45. So I've got that one. All right. So let's see. If that is 45, then what I'm looking for is the blue angle. So it's 90 degrees. It's 90 degrees between here. Because this is parallel to, or tangent to the green bar, and this is perpendicular. So that's 90. So if this is 45, this angle right here is 45, then this angle right here is 90 minus 45. That would be 45 degrees as well. Okay, now that I have those angles, I can simply add some forces in the r and theta direction. So let's see if I can get this to behave properly. So what I want to do is sum forces in the r and theta. So in the r direction, I have PC times the cosine of 45 degrees let's see, I have no PS, I have some mg, so let's see, this is this guy right here is 45 degrees, so this is 45 right there as well. So I'm looking for this component of the mg. That would be mg sine 45, and it's backwards, so that would be a negative, minus mg sine 45. Okay, keep going around. You have a mu k PC, you have a piece of that. So you have some mu k PC. And that value would be cosine of 45. And he is in the positive direction. And then you have finally mu k ps plus mu k ps. And that's all of them, and that equals the mass of these guys times r double dot minus r theta dot squared. Then what we'll do is we'll sum the forces in the theta direction. In the theta direction I have some PC. PC sine 45. That's a positive. I have all of PS. Let's see, I also have some MG. And that would be the cosine. Uh-oh. Yeah, I blew it. Did I? Okay. MG. This line. Carry that line down. Yeah, that's right. It's 45 degrees. MG. Let's see. It was sine 45. This one will be cosine 45. He's negative. Let's see. Mu K PC. I have some of that. He's also negative. Minus mu K PC. And I believe his angle is 45. That would be the sine. Yeah, use cosine before, so it would be sine of 45. Let's see, and I think that's it. All right, and that will equal mass of this guy times 2 r dot theta dot plus r theta double dot. Okay, now let's take a look at the equations and we'll circle the number of things that we don't know. So right now you don't know PC, you don't know PS, you don't know R double dot. The R you can put in because you know the theta, so you can get the R. The theta dot is given, if I'm not mistaken. Yep, theta dot is 4. So, and then in this equation down here, I've counted PC, I've counted PS, I have not counted R dot. So R dot's unknown. Theta dot is known, it's 4. And it says it's a constant, right? So theta double dot is 0. So that term right there is all gone. So how many things are in blue circles? 1, 2, 3, 4. So I have 4 unknowns, and I have 2 equations. So rather than panicking, right, look at the types of unknowns that you have. You have an R dot and you have an R double dot. Well, you know you can get those because this is 1 degree of freedom. That means you give me any 1 dot term, which you did. You told me theta dot. I can find any 1 dot term I want. If you give me 1 double dot, I can find any double dot. So the R dot is findable, and the R double dot is findable. And once they are found, you will have 2 unknowns left with 2 equations. So the problem now is to find the R dot and R double dot. So let's go back over here. R is equal to 1.6 cosine theta. So R equals 1.6 cosine of theta. All right. You put in 45 degrees and you can get the R, which I did before, and that's a 1.13. That's R. Okay. R dot is equal to a negative, I have to use a chain rule, 1.6 sine of theta times theta dot. And so then plugging that in, that would be 1.6 times the sine of 45 is 1.13, so that'd be a negative 1.13 times theta dot is 4 times 4. So we'll get that in a minute. R double dot equals, and you take a derivative of this, that's a product formula, and so that would be a negative 1.6 times the derivative of the first term, that'd be cosine theta, theta dot, chain rule, times the second term, plus sine of theta, times the derivative of the second term. That's R double dot. This guy is 0, because theta double dot is 0. And so let's see, this would be negative 1.6 cosine of theta times theta is 4 times 4 is 16. 1.6 cosine of theta is 1.13 times 16. Okay, so I'm going to pause and get these things. I'll talk to them. Okay, so anyway, that's the values I get for those guys, and then what you're going to do is put them back over here. So R dot is 4.52, so this is a negative 4.52. Theta dot is 4, and so you know everything there. And then up here, theta double dot is 16 something, 18.08. So this guy is minus 18.08. The R is 1.13, I think. 1.13. The only thing that's left that's unknown is PC and PS. So you just solve those two equations simultaneously and get the two forces, and that gets you the solutions for that. That's it.